So we have the first one here. State which of the following relations given by the arrow diagrams below are functions. So as we identify which ones are functions, we'll be able to know what then functions are. If we go to the first one, question 1A, we find arrows moving, one from A to 1, one from B to 2, one from C to 3, and one from D to 4. Our job is to check if the arrows from the left, let me call it A, if the arrows from A to B, now if all the elements in A are mapped, that's the first question. The second question is, the mapped elements of A, how many times are they mapped on the right? We want them to map only once. The elements in A should be mapped only once. Once meaning only one arrow must move from an element of A to an element of B. So, as we can see the first one, all the elements are mapped, the first thing. The second thing, they are mapped only once each. So it means that this is a function. So the first one is a function. Okay. The second one, we have an issue with B. B is not mapped anywhere. But we demand that all the entries of the left must be mapped. So because B is not mapped, this is not a function. Okay. We go to C. A is mapped, B is mapped, C is mapped, D is mapped. How many times is A mapped? Once. B, once. C, once. D, once. Where they are mapped, we don't care. Our interest is, are they mapped? So yes, they are mapped, and each is mapped only once. So again, it's a function. D, A is mapped, B is mapped, C is mapped, and D is mapped. So how many times is A mapped? Only once. B, only once. C, only once. D, only once. So again, we have a function. We go to E. A is not mapped. B is not mapped. So not a function. We go to F. A is mapped. B is mapped. C is mapped. D is mapped. And each mapped once. It's a function. Then now we go to question 2. Given that a function g is defined as x squared minus 6, are we able to find g of 4? So g of 4 is simply a function where we go where there's x, we put 4. That will be 16 minus 6, that's 10. And g of -4, the same thing will happen. -4 squared minus 6 again, that's 10. G of 2, 2 squared minus 6, that's -2. There it's Q, okay? Now we need to find the possible values of A. If G of A is equal to A. This means you go to G, where there is X, they have placed A inside here. So G of A means a squared minus 6, and then equate it to g of a is equal to a. So you equate it to a. And then you form a quadratic now because we have a quadratic. So we have a squared minus a minus 6 is 0. So the product, we multiply a 1, the coefficient of a squared times -6, we get -6. And then the sum, we get -1. So the product is a squared minus 3a plus 2a minus 6 is 0. So then we'll get a, and then a minus 3, 2a minus 3 equal to 0. So then we understand that this means a is 3 or a is -2. And they are all real values. So we submit all of them as the solutions, A and B. So the idea there was where there is X, you substitute A, and then after you're done substituting, you equate again to the same A because that is the value we get on the right-hand side. The left-hand side is the action in the function, and then the answer is given on the right again to the A, so we'll have to equate it to A. Do I have any questions so far? So please, if you can't see, you say quickly so that I'm able to reshare. So now the challenge is going to be, when I reshare this whole thing is going to go. Once I share, it comes back later. Okay, let's move to the next one. To the same question 2b, we have a function f of x, a function 2x plus 1. Find f of x squared. So this one, we just place 2x plus 1. This is our f of x. Now we are told we should square it. So we square it and then we are done. The next one, f of x squared. So it means where there is x here, we substitute x squared. So we have 2x squared plus 1. We have 2x squared plus 1. Like that. Hello. Okay. Okay, so you just place where there is x, you put x squared. And that will be enough.
Oh, karibu chama.
What's happening?
Mm.
Oh, what's that?
Bwe tungapunzira tunsabiri.
So the other one is f of x. So in the function f, where there is x, you put the whole function f. So it will be 2f, it will be 2f plus 1. It will be 2f plus 1. And then we check which one is f now. F is the whole thing 2x. F is the whole thing 2x plus 1. So where there is x, you put back the whole f. That is what we are doing there. And then you can simplify there now. So you have 2x. So you have 2 by 2x, that is 4. So this will be 4x plus 4 plus 1, which is 4x plus 1. Which is 4x plus 5. So we can finish after that. Okay, let's go to question 3 now. So I'm moving on this speed until you ask. So when you see that you're behind, please you ask so that I get back and explain. Don't wait until the whole question is done for you to ask. Please. Question 3. A. Yes.
Question B1, what is 2x plus 1 squared? Is it okay if you expand it or just leave it like that?
Yes, even if you expand the way it will see the same. But we like factorize things where possible. And that's when you expand, then you can add some other number. Like in this case, here you have to expand so that you include the one. Okay, we go to 3a. The function g is given by g of x is equal to ax squared minus b, where a and b are real numbers. Now, if g of 2 is -5 and g of -1 is +2, find the values of a and b. So we're going to have two equations here. G of 2, meaning in the function where there is x, substitute 2. So we'll have a 2 squared minus b. That will be 4a minus b, and then equate it to -5. The other one, g of -1, that is a -1 squared minus b. So this is a minus b, and equate it to +2. So now we have two things. We have 4a minus b equal to -5. We also have a minus b equal to 2. Simultaneously, if we subtract, we'll have 4a minus a, that is 3a. And then -b minus b, that will be 0. Then -5 minus 2, that's -7. So a is equal to -7 over 3. And then you pick any of those two equations. So you can, if we pick this one, where there is a, we put -7 over 3, and then minus b is equal to -5. So we take the other side. So we have -b is -5 plus 7 over 3, like that. And this is going to be -b is equal to 3 common denominator, then -15 when you multiply 3 by 5 plus 7. That is -8 over 3. Then you divide by -1, you divide by -1. So b is equal to 8 over 3. This is what we have. Again, any questions? Any question? Okay, we move. We go to question B of the same three. Find the range of each of the functions for the given domain and state if the function is one-to-one or not. Okay. So we want to find the range for each. The domain is already given. The first one, question 1. This is 3B. Question 1. F of x is x minus 2. And the domain given is from -2 all the way up to +4. We can only use the values of x from -2 to 4. Now, if we use -2, we have -2 minus 2 equal to -4. If we use +4, we will have 4 minus 2 equals 2. Because the power of x is 1, as we can see, and it's not in the denominator. It's a linear function. The power of x is 1, and it's not in the denominator. It's not in the root. It means that the range is given by these boundary numbers from -4 to +2. These are the only values of y that you can get from the values of x that are allowed to be used in the function. I hope you get that. For functions like 2, which has a square, f of x is equal to x squared, you check if in the interval given there is a 0. If 0 is there, it means that the minimum value, the lowest value, the left one, is going to come from when you use that 0. Because the other numbers will be giving us the same values, whether negative or positive, because the x has been squared. If we use -3, we have f of -3 giving us -3 squared, which is equal to 9. If we use 3, we have 3 squared, giving us 9. The two different sign values are giving us the same number. This means that we cannot get the left boundary using the number. Now, what we need is to use a 0. So a 0 is going to give us, when you say 0 squared, you get 0. So what does that mean? That means that the range is going to run from 0 all the way up to 9. But look, I've included them before I check what is there, right? So we have less, there is no equal to here. There is no equal to here. So it means I need to go back to my solution. I need to go back to my solution and change the boundaries. So now I'm going to leave out. Do I include 0? Yes, because 0 is in between here. So 0 will be included. But 9 won't be included because the number which we have used, which is the 3, which has given us 9, is not included in this function. Okay, that should be okay. Any questions there? Need to ask now at least. Any questions there? So, okay, that's okay. We go to the third one, where we are given the domain to be x greater than 1, and the function is a fraction. When x is bigger than 1, it means that all the values, so all the values that are going to get for x that are going to use down there, the denominator will be larger than 1. Is that true? Not necessarily. So what this means is that we have f of x is equal to 1 over x minus 1. So if I use 1.001, this is going to be, so if this is my x, or if after I subtract, I get 1.001 as the denominator, then I'm going to have 1 over 1.001. Now you understand that 1.001 is 1 over 1,000. This number is 1,000. This means that the values are going to become big, especially when we deal with the interval that is between 0 and 1. We'll be getting very large values because those numbers are happening in the denominator. Then when you reciprocate, they become very big like this one. So this means that the only thing we cannot get here is a negative because x will be positive. X is greater than 1. So we're going to be getting positive from down, but they can be as big as possible. They can also be as small as possible. For example, if x is equal to 1001, this is 1001. When you subtract 1, you get 1000. So you have 1 over 1000, which is 0.001. Again, a very small number. This means that our range is going to run from just excluding 0, but all the way up to infinity. We can't get 0 because the numerator is a constant 1. The opposite of this very one is the one that is down here, the fourth one, where now we have f of x is equal to 1 over x squared plus 1. This means that at each point I'll be adding numbers to this one. So I'm always going to have values greater than 1. So the values greater than 1 when you divide by 1 up there, so this demonstration is not good. This number, is not what I think. So if I use a 0 here, that's when I can demonstrate that I will have 1 over 1 over 1. Okay. But then the other side, whatever value in the denominator here, because this guy is coming as a positive value, so I will always have to add to 1. So when I add to 1, then I will be getting large values that are bigger than 1. So n number bigger than 1, and then I divide in 1, I'm sure that the numbers I'll be getting will be less than 1. But if x, is x allowed to be 0? Yes, because it's all real. So when x is 0, I can get the actual one. So it means that the range for this one changes now. It cannot be 0. but then it can only go as far as 1 because all the values of x are making the denominator bigger than 1. No matter how big it can be, 1.1. Because it's bigger than 1, when you divide in 1, you're going to get a value that is less than 1, or at least equal to 1 if that x is equal to 0. Yeah, that's what I'm just saying. So this one, gives us a domain of 4A. So the domain of 4A is this one here. It has been given already. The domain is OR. And the range of this very one, again, is this one that you have found here. The one that will change is this guy, because initially we are given a restricted domain. But now we'll use a free domain, taking it as a fraction, so we only consider the denominator. Once the denominator is not allowed to be 0, whatever makes it 0, we remove it, and whatever remains is part of the story. That means it's part of the domain. Okay. So, I'll give you a homework to what is the homework? The homework is I want you to do question 4. This is the exercise I'm giving you now. Question 4, you start with G, this one, and then go to B, this one, and then go to H, this one, and then go to F, this one, and then try if you can solve I. Yeah, that's those. That's those. And then for E, I want you to find X that will make F to be undefined. So our whole class tomorrow will be centered on how to find the domain and the range of different functions, including the test papers. But for now, you do that part. And encourage others to join, so they're not left behind.